Welcome in my lecture. Now in this lecture we will discuss cover of elements of forces. So to understand this topic, here we start our topic with the example so you can better understand. So here we consider one force. Consider shape A is equal to 1, 2 and 3. And here we define relation on state A is less than or equal to and is force F. So A, state A with the relation is less than or equal to is force F. Now see here, one related with 2 and 3, one less than or equal to 2 and one less than or equal to 3. Our relation is less than or equal to, so one related with 2 and one also related with 3. One less than or equal to 2 and one less than or equal to 3. Now in first case, X directly related with 1. One directly related with 2. Here not exist any element between 1 and 2. Here not exist any element between 1 and 2. Now in second case, 1 related with 3, but here there exists one element and the element is 2. 1 less than equal to 3. So 1 less than equal to 2 less than equal to 3. And this 2 is element of set A. So here 1 related with 3, 1 related with 3, but via 2. So in first case, 1 directly related with 2. There not exist an element between 1 and 2. Now in second case, 1 related with 3 but via 2. So in first case, 1 directly related with 2. So 2 is 4. 2 is 4. Cover of 1. Now in second case, 3 related with 1 related with 3 but via 2. So 3 is not cover of 1. So this is the definition of cover of element. If X directly related with Y, then Y is called cover of X. Now if X less than or equal to Z less than or equal to Y, means X related with Z and Z also related with Y, then Y is not a cover of X. Now in first case, X directly related with Y. In second case, X related with Y but via Z. So in first case, Y is called cover of X. In second case, Y is not a cover of X. Now here we also find the cover of 2. Here we also find the cover of 2. Now same thing apply for 2. So 2 just directly only related with 3. 2 less than or equal to 3. Here 2 only related with 3 and 3. Here not exist any element. Here not exist an element between 2 and 3. Here not exist an element between 2 and 3. So 3 directly related with 3. 3 directly related with 3. So 3 is called 3 cover of 2. 3 is called cover of element 2. Now here we see for last element 3. And observe here 3 not related with any element of A, because 3 is the biggest number in our set A. So 3 not related with any element. So here we not find the cover of element 3 because 3 not related with any element. So to become cover of element, condition is X related Y. But here 3 not related with any element. So here we not find cover of 3. So shortest definition of cover of element is if X related with Y, then Y is the cover of X. If X related with Y is Z, then Y is not a cover of X. This is the definition of cover of elements. So here first we define the definition. Cover of elements of forces. Okay. So let A relation, whatever relation we have given. In our particular example, our relation is the less than equal to. If our set is S and D, then our relation is the division. If our set is the power set of S, then with the relation power set of S. So let A relation be a process. Now for X belongs to A, there exists Y belongs to A, so that X directly related with Y, then Y is called power of X. And in second case is there exists Z belongs to A, so that X related with Z related with Y. So in second case is X related with Y, but Y are element Z, and this Z element is also of set A, where X not equal to Z and Z not equal to Y. Then Y is not a power of. So this is the definition of power of element of process. We find power of each element of set A except the last element. Depends upon the whatever relation we have given. Now here we see example. Here we consider example number first. Consider set A is equal to 1, 2, 3, 4. And here we consider relation as A less than or equal to is process. So here we find the power of 1, 2, 3. Here we find the power of 1, 2, 3. And here we not find the power of 4 because 4 not related with any element. So here we find power of. So 1 directly related with 2. 1 less than or equal to 2. So 2 is the power of 1. And here we use this notation to denote the power. Read as the 2 is power of 1. Now see here, 1 also related with 3 and 4. 1 less than or equal to 3 and 1 less than or equal to 4. But 2 is also less than or equal to 3 and less than or equal to 4. So 1 related with 3 and 4, but Y are 2. So 3 and 4 are not a power of 1. So here just exists only one power, 2 of element 1. Now here we will find the power of 2. So 2 directly related with 3. 2 less than or equal to 3. So power of 2 is 3. Now see here. 2 also less than or equal to 4, but 3 also less than or equal to 4. So 2 related with 4, but Y are 3. So 4 is not a power of 2. So power of 2 is only 1, 3. Now we will find the power of 3. And 3 is only related with 4. 3 less than or equal to 4. So power of 3 is 4. And here we not find the power of 4 because 4 not related with any element of set A. So here we not find the power of element 4. So this is the power of 1, 2 and 3. And this is the power of element of process. Power of 1 is 2, power of 2 is 3, power of 3 is 4. Because 1 directly related with 2, 2 directly related with 3, and 3 directly related with 4. Now we will consider another example. Consider set A is equal to 1, 2, 3, 4. And here we check relation A greater than or equal to is process. Now in first example we consider relation is less than or equal to. In second example we consider the relation is greater than or equal to. So here we find the power of 1, 2, 3 and 4. Now but in this example, here not exist an element, which related with this 1. So 1 1 not related with any element of say A, because 1 not greater than or equal to any element, so 1 not related with any element. So here we not find the cover of 1. Here we start with the element 2. So cover of 2 is cover of 2. So now 2 greater than or equal to only 1. 2 greater than or equal to only 1. And see here not exist an element between 2 and 1. So cover of 2 is 1. Cover of 2 is 1. 2 greater than or equal to 1. So 1 is the cover of 2. Now second, cover of 3. So 3 greater than or equal to 3 greater than or equal to 2 and 3 greater than or equal to 1. So here first is 3 directly greater than or equal to 2. Here not existing element between 3 and 2. So 2 is directly cover of 3. But now you see second case, 3 greater than or equal to 1. But there exists one element 2 between 3 and 1. So 1 is not a cover of 3. 1 is not a cover of 3. Now to find the cover of last element 4. So 4 greater than or equal to 3, 4 greater than or equal to 2, 4 greater than or equal to 1. But 4 directly only related with 3. Only related with 3. Now see, 4 related with 2, 4 related with 1. But why are 3? Here exists 4 related with 2. But there exists element 3 between 4 and 2. So 2 and 1 are not a cover of 4. So this is the cover of. So cover of 2 is 1, cover of 3 is 2, and cover of 4 is 3. So this is the second example related cover of element of 4 set. Now here we see example number 3, 1, SB. Here we consider example number 3. Now see example number 3. Here we consider set 4 set LC. S6B is 4 set. S6B is a 4 set. Here our relation is division. In first example our relation is less than or equal to. Second example our relation is greater than or equal to. Now in this example our relation is the division. So whatever condition here becomes x directly divide y. X directly divide y, then y is the cover of x. But if x divide y and x divide z and z divide y, so x of course divide y, f of course divide y, but y are z, then y is not a cover of x. X directly divide y, then y is a cover of x. Here x divide y, but y are z, then y is not a cover of x. So here we first of all write the S6. So S6 contains elements 1, 2, 3 and 6. All are factor of 6. Now here we find the cover of 1, 2, 3 and 6. So here we find with the 1. Because 1 related with all elements. 1 divide 2, 1 divide 3 and 1 divide 6. So cover of 1 is, so here 1 divide 3, 1 divide 3, 1 divide 6. So 1 related with 2, 1 related with 3 and 1 related 6. Now here we find 1 related with which element directly, which element with the directly. Now see first case, 1 divide 2, 1 divide 2. So here not exist any element between 1 and 2. Who divides 2? So 1 directly divides 2. So 1 directly related with 2. Here not existing element in S6 which is related with 2. So cover of 1 is 2. Now see again. Next one is this. 1 also divide 3. 1 also divide 3. So here not existing element. Here not existing element between 1 and 3. Here 2 not divide 3. Of course, 2 is the cover of 1, 2 is the cover of 1, but 2 not divide 3. So 2 not related with 3. So 1 also directly related with 3. So here, cover of 1 is 2. 2 and 3. One directly related with 2 and one also directly related with 3. So cover of 1 are 2 and 3. 1 divide 2 and 1 also divide 3. But 2 not divide 3. These 2 and 3 not related with each other because 2 not divide 3. So 1 directly divide 2 and 1 directly divide 3. Now see here. 1 divide 6. 1 divide 6. If we write the 6, then observe. Earlier both elements 2 and 3. 2 and 3 both divide 6. 2 divide 6 and 3 divide 6. So 1 divide 6, but why are 2 and 3? So 6 is not a cover of 1. 6 is not a cover of 1. Because 2 and 3 both divide 6. So 6 is not a cover of 1. Now to find the cover of 2. Cover of 2. So here 2, 1. 2 not divide 3. 2 not divide 3. So 3 is not a cover of 2. Now we go forward. So element is 6. 2 divide 6 and observe 2 directly divide 6. 2 directly divide 6. So 6 is the cover of 2. Now last element is cover of 3. And 3 only divide 6. 3 only divide 6. And 3 directly related with 6. So cover of 3 is 6. So cover of 2 and 3 both is 6. Now here we not find the cover of 6. Here we not find the cover of 6 because there not exist an element in S6. A 6 divides that element. So here not exist an element in S6. So 6 not divide an element remaining 1, 2 and 3. So here we not find the cover of 6 because 6 not related with any element. So cover of 1 is 2 and 3. Cover of 2 is 6 and cover of 3 is 6. Now let me consider another one more example. Example number 4. Here we consider set A equal to AB and here we define our relation on power set of A. So power set of A is nothing but the collection of all subset of set A. So all subset of A is 5 singleton A, singleton B, A, B. So this is the power set of A. Here we define our relation and we already know power set of A with the relation subset or equal to is 4 set. Now here our relation is the subset or equal to. So here we find the cover of 5. So here we try to find the cover of element of 4 set. So cover of first element is 5. Now see here, 5 is a subset of singleton A, 5 is a subset of singleton B, and 5 is a subset of singleton AB. So cover of 5 is first of all singleton A. 5 directly subset equal to A, and 5 is a subset of B. 5 is a subset of singleton A, and see 5 is also subset of singleton B. Then observe. Singleton A not a subset of singleton B. So singleton A not a subset of singleton B. So singleton A not related with singleton B. But 5 is a subset of singleton A and 5 is also subset of singleton B. So singleton A and singleton B both are the cover of 5. And singleton A and singleton B not related with each other. Same in our case. Here 1 related with 2 means 1 divide 2 and 1 divide 3, but 2 and 3 not related with each other. Same case right here. Now see here, singleton AB. So 5 is a subset of singleton AB, but observe, singleton A and singleton B both are the subset of singleton AB. So singleton AB is not a cover of 5. Here we consider 6. So 2 and 3 both are related with 6. So 6 is not a cover of 1. Similarly here, set AB not a cover of 5 because singleton A and singleton B both are subset of AB. So set AB is not a subset of singleton of empty set 5. Now here we find the cover of singleton set A. So now see here, singleton A, not a subset of singleton B. So singleton B, not a cover of A. So singleton A is only a subset of singleton AB. So directly related with singleton AB. So singleton A is a subset of set AB. So set AB is a cover of A. Similarly, cover of singleton B. So singleton B is only a subset of set AB. So directly related with set AB. So set AB is a cover of B. In our case, 2 and 3 only divide 6. So 6 is cover of 2 and 3. Same case right here. Set AB contains singleton A and singleton B. So set AB is subset of singleton A and singleton B. And same here we not find the cover of AB because here not exist any set. Here set. So singleton AB not a subset of any set. Set AB is not a subset of any set. So set AB not related with any element. So here we not find cover of element AB. So cover of 5 singleton A, singleton B. Cover of singleton A is set AB and cover of B is set AB. I hope you understand very well what I say, and this is the most important topic. Now in next lecture we will discuss the H diagram, and this H diagram also related with the cover of element. If you know very well about the cover of element, then you can easily understand the topics of the H diagram. Now try to find in homework cover of element of four sets. First one here we consider S10D. Find the cover of element of S10. Second one, S50 relation is the division. Third one, power set of A, subset equal to A considered as the set A, B, C. Now try to find all these three ones. First one S10D. So S10, first of all write the set S10. So set of all factor of 10, 1, 2 and 5, and try to find the cover of each element. Similarly S50D. Now third one is the power set of A. So first of all find the power set of A. So power set of A is nothing but the subset of all set. Example 3 is similar as we see earlier example number 3 are the same. So try to find these three homework. Now today we stop here. In next lecture we will discuss H diagram, and this is the last topic of this chapter. Thank you, good luck, and thanks for watching this video.